This is an ice cream distribution facility. It used to be a Kentucky Fried Chicken distribution warehouse, and we have done a bunch of work to it to make it fit for distribution of ice cream. These are medium temp boxes. They also distribute milk here. We have complete control of this facility remotely. This is the ice cream box. This holds at about a minus 10 degrees. This place has been running for about 20 years. We've got a variable speed refrigeration system that we have completely upgraded the controls on just about 5 years ago, and it's been running flawlessly ever since. This is the loading dock. It holds milk at an adequate temperature for distribution into the trucks. And these are the medium temp boxes where they hold product at 32 degrees, 34 degrees. This is their distribution fleet. They run ice cream all over Northern California, ice cream and milk. Coming up on the machinery room where all of the work takes place. And there is a evaporative condenser out here that extracts all the heat out of those spaces through the compressors. When we took this place over, it had an old Teletrol refrigeration controller that managed the variable frequency drives. All the drives were dead, everything was running at full blast, and the controller was completely dead as well. So we installed this Emerson controller and all the interface boards that go with it. All the interface boards are here. Those are reading all the temperature sensors on the evaporator coils and in the spaces, and measuring head pressures and responding, allowing the computer to respond and tell the VFDs how fast each unit ought to be running. We've got the refrigerant receivers here. We converted this facility over to R507 refrigerant, which is now being sunsetted, but it's still legal to use. There's a refrigerant subcooler there that maximizes the efficiency of the low temp system using waste energy from the medium temp. There are sensors for oil pressure, oil level, oil separators. It's quite a complex system, but it runs flawlessly. It's about 30 years old. We just renewed it to modern controls about 5 years ago. This evaporative condenser rejects heat through water evaporation. As you can see, there's scale and algae on these louvers. We've got a permanent solution for that. We're about to install it on this facility to permanently eliminate scale and algae and bacteria without the use of chemicals. This is not the kind of facility you can just come out of school and start servicing. It takes some acclimation and some familiarization to be able to handle both the control side and the mechanical operation side. But that's what we do. We train people for that. This is a grocery store that's got a bunch of antiquated air-cooled refrigeration up on the roof where it's hard to access. We're going to be moving the refrigeration for the produce and beverage cases behind this fence. It's going to be super efficient water cooled. This is the produce case condenser. It's on its own 100 amp circuit. It's very old and very inefficient. And then down at the other end of this line, we've got the beverage case condenser. It's on its own 100 amp circuit. And it is very old and very inefficient. What we're going to do is mount the refrigeration condensers on the ground where I showed you, and they will be right outside where the cases are, So we'll be able to minimize the refrigerant used in that application. Reducing refrigerant use is in everybody's best interest. It reduces the amount of cost if you should have a leak, and it reduces the first cost of installing the system. So piece by piece, all of this stuff is going to be converted to water cooled. These two, the beverage case and the produce case condenser, are both going to run off of one. With water cooled, we reduce the current draw by about half. So when we're done with all of this conversion, their $6,000 a month energy bill will be about half of that. For years, grocery stores had one-off refrigeration systems that were one condenser for one set of cases. Then there was a big push to move toward rack refrigeration systems where you'd have a whole bunch of compressors all in one room and distributed refrigerant lines out to the cases throughout the store. Now things are moving back towards a one-off type of strategy because of the reduction in refrigerant use and because of the high cost of converting over to CO2 systems. Jerico is at the leading edge of the one-off water-cooled conversion process. Part of what we'll do on this particular grocery store project is pull power from these panels and run new power out to that location. It's all the way down at the end. So we'll run overhead conduit lines out to the outdoor condenser area and then set a waterproof circuit breaker panel to handle the two condensers for produce and beverage. This is all the cases that'll get replaced. We've got 60 feet of produce case and 44 feet of beverage cases. Not everything we do is on big systems. We also work on small refrigeration equipment as well. So here's our completed project. The condenser is off of the roof now. All the heat from this freezer is not going inside the building, it's going outside the building. We have placed a new sub panel here. We're distributing the power over around there, up the wall to the condenser on the roof. We got a new door on here. We've got new LED lights inside. That evaporator is gone from there. We've got a good evaporator with a communications package on it, so we can see it from our phones or from the office, see what's going on with the refrigeration system, get alarms if there's a temperature issue. I'll show you where the power goes. Up the wall, through the ceiling. We've got a watertight penetration up there. And here we are up on the roof, walking up on our installation. Here we've got our tower, our recirculation lines over to the compressor. We reutilize the old receiver for a number of different reasons. And our discharge line and liquid line going down to the freezer. Inside the condenser is, or the condenser cabinet, is the condenser we built. It's got a much smaller compressor than was in use before, much smaller electrical footprint. There's our recirculating pump for the tower. So it's good, it's done, it's holding temp.